Okay, I think I'm going to run through this one pretty quick. I think it's going to be kind of a short one. So if you want to stop or pause the video at any time to try to finish it or get further on your own or look for a theorem, make sure you do that. But at this stage of the game, I think if you're already to this one, you're probably okay saying that we're just going to use definition of complementary angles. Actually, I never finished writing the given up there. So they told us we had a couple angles that are complementary. Well, then that means their measures are going to add up too. So measure of angle ABD plus the measure of angle DBC are going to add up to a total of 90 degrees. So we say that. And we're looking at my pictures, and I have, have some other things going on here. It looks like I have some linear pairs. I have some vertical angles. So if we need some more, maybe we can get some more. Well, let's just see what happens. A, B to D is the angle that we're looking at. That's 40 degrees. Well, it looks a little bigger, but that's what they tell us. And we're trying to prove that measure of angle 1 equals 50. So how do you know that measure of angle 1 equals 50? Well, it's because DBC equals 50. Can we prove that? And then maybe what type of angles are angles DBC and angle 1? Now maybe you could be thinking about what type of angles, because we're going to use that. So let's show that DBC is 50, and then I think we'll know the other one is the same. That's our thought process. We've just got to state that and show that and justify that. Got a couple equations set up. I'm going to use replacement rule. We've used that in every single proof so far. Not that we're going to use it in every single one, but so far we have. I'm going to replace what? ABD I can replace with 40 degrees. And then I think at that point we're going to be able to say measure of angle DBC equals, subtract 40 from both sides, you'd get 50. So what property says, again, pause the video if you need to, but I'm looking for the property that says you can add or subtract something from both sides of the video. So go look for that one, APE. If you knew that one already and don't need to pause, I'll just go ahead and write it in. Additive property of equality says you can add or subtract something from both sides of an equation. And I would really like to say angle 1 is 50, which is the same, but why? Why is angle 1? Here's what I want to say. I know that they are. This is the reasoning in my head, but I got to say it. So what allows me to say that measure of angle 1 equals the measure of angle DBC? So what type of angles are those? Again, the 50 and the 50 that I had labeled there that was going to help me know that angle 1 was going to be 50. Vertical angles. Definition of vertical angles allows me to say their measures are equal, and all I would have to do is, instead of saying, well, you could do it either way, I could replace the DBC with 50, or I could replace the DBC with angle 1 in the first one. I'm going to go ahead and say measure of angle 1 equals, instead of DBC, 50. That's just replacement rule, and that's what they wanted us to show. Not just know that it's going to work, but be able to prove that, justify that, show somebody else, and tell them why it would be what it would be.